Students do the homework help video, page 13, 63 through 67 odd, page 21, number 52, and page number 28, 65 through 77 odd. Let's jump right into these. Okay, number 63. Jean has an apartment, and one room is shaped like a square, okay? So she has a square room measuring 12.2 feet along the base. Now, let's think about that, okay? Pretend you're up in the air, hanging from the ceiling, looking down on the floor. It's a square. So if the length of one wall, or the base of one wall, is 12.2, then the length of another side would be 12.2 also, because the room is a square, okay? So you're up on the ceiling, you're hanging from the ceiling looking down on the floor. She wants to do wall-to-wall carpet. Now what that means is she wants carpet to cover the entire floor. That's all that means. When it says wall-to-wall carpet, that simply means she wants carpet covering the entire floor, okay? So the question is, how many square feet of carpet does she need? Now students, please think about this. If I asked you to find how much trim she wanted to put around the room like this, that would be what? Perimeter. But if I'm asking you how much carpet needs to go on top of this floor, that's area, and that's why it says how many square feet does she need. So we should all know by now how to find the area of a square. It's simply side times side. So I'm going to take 12.2 times 12.2 with my calculator. Let me grab that real quick. And you will get this right here. 148.84. Now, this is feet. So my answer is square feet. So, how many square feet? How many square feet of carpet does she need to buy to carpet this floor? 148.84 square feet. Alright. Okay, number 65. Okay, we have a cubicle storage space inside of a fireproof safe, okay? And it's 12 inches. What is the volume of the storage space? Now stop and think. It says a what? Storage space. Cubicle. That means you have a cube. Okay? So when it says each dimension of the cube is 12 inches, that just simply means that you have a length of 12 here, 12 here, and 12 here. Now in your notes we learned the volume of a cube is length times width times height, or you could say side cubed. Either way is fine, okay? So to find the volume we have 12 times 12 times 12, or you could say 12 cubed. Now this formula only works when you're talking about cubes, okay? And we are dealing with a cube. Alright, let me grab my calculator real quick. 12 times 12 times 12 is 1,728. Now, what are these 12s? Inches, feet, yards, meters, centimeters. They are inches. So then my answer would be cubic inches. So the volume of this safe is 1,728 cubic inches. Number 67. The formula for the volume of a pyramid is, are you ready? They give you the formula right here. The volume of a pyramid is, look guys, 1/3 times the height times the area of the base. I'm gonna put A of B, area of base. Forest Pyramid in Moody Gardens near Galveston, Texas. Now look at that thing. Looks beautiful, doesn't it? That's really cool. I would like to see that someday. It's a big glass pyramid. It's 100 feet high and 200 feet along each side of its square base. What is the volume? So, we're going to try to find the volume of this pyramid. They gave us the formula. We only have to find two things. We have to find the height of the pyramid, and we have to find the area of the base. Alright? Well, they give us the height right here. It's 100 feet high. So I'm halfway done. Now, the area of the base. Now what that means is you have to picture the base in your mind and then find the area. For example, see this top of the pyramid? Pretend you tied a rope to yourself right there. Alright? And you were hanging down from the ceiling, looking at the ground right here. What would the base look like? Well, it says right here it has a square base. So if you were hanging on the inside of this pyramid from the top and looking down the floor would look like this. It would be a square. Okay? Now, it says the square has 200 feet along each side. So each side is 200 feet. Okay? So how do you find the area of a square? Well, side times side. So 200 times 200 is 40,000. 200 times 200 is 40,000. Okay, so we're good. We found what we needed. We needed to know the height, and we have that. We needed to know the area of the base, and we have that. So let's find the volume. Here we go. 1/3 times 100 times 40,000. Well, I can do this in my head real quick. 100 times 40,000 would be 4,000,000. 100 times 40,000 is 4,000,000. And now take 1/3 times 4,000,000. Okay? So with your calculator, and hopefully you guys know how to use the fraction button on your calculator, okay? It's 1/3 and then times 4,000,000. And if you type that in correctly, you will get 1,333,333.3 repeating. And that's going to be cubic feet, because all of your measurements were in feet. 100 feet, 200 feet, and it's cubic because you're solving for volume. And that's it. Not too bad. Okay. Number 52. A similar problem where it's going to take a formula they give us, substitute numbers in, and solve. Alright? The area of a trapezoid with parallel bases of these lengths and this height is found by this formula here. There we go. Find the area of the trapezoid whose height is 2. So I have 1/2 times 2, and whose bases are 6 and 10. Now some of you might say, well, Mr. Earhart, which base is 6 and which one is 10? It really doesn't matter since you're adding them. It's just going to be 6 plus 10. Or you could put 10 plus 6. It really doesn't matter. Okay? So here we go. We have 1/2 times 2 times 16. Alright? And if you multiply all of that together, you will get 16. Now, everything is in meters. So we're dealing with meters. And since we're dealing with area, it's not cubic. It's going to be squared. So your answer is 16 square meters. Alright, okay, moving on to our last page, number 65. And here we go. Your school is building a new computer center. You have a total of 400 square feet available. Each station requires 20 square feet. You want to find out how many computer stations can be placed in the new center, so you write this equation to help you. What does 20 and x and 400 represent? Well, let's see real quick, okay? First of all, let's think about this. Each station requires 20 square feet. So if I get one station, that's 20 square feet. If I get two stations, that's 40 square feet. If I get three stations, that's 60 square feet. Okay? Do you see what I'm doing here? So, every time I take 20 and multiply it by the number of stations, then I have my total square footage that I can use. So, here we go. Here's my equation. Now, obviously the 20 stands for each station, because each station requires 20 square feet. So, 20 stands for, not each station, but 20 stands for the space of one station. That's how much space you need, okay? 400 is the total space you have to use. Total space available for use. Now, what does X stand for? Well, that's why I showed you this over here. It's number of stations. 20 times 1 is 20 square feet. 20 times 2, if I have 2 stations, 40 square feet. 20 times 3, if I have 3 stations, 60 square feet. So, X is your number of stations that you're going to have. Alright? Now think about it. What's the answer? It says solve the equation. Well, the answer is 20, because 20 times 20 is 400 square feet. So here's the space of one station. 20 times 20 stations equals 400 square feet. So the answer is 20. I will have the space available for 20 stations, because each station is 20 square feet, and 20 times 20 is 400. Alright, let's try another one, 67. Okay, you're buying gas, and you're taking a trip with the family of a friend. You have $65 to help pay for gas, okay? It costs $15 to fill the tank. Can you fill the gas tank 4 times? Well, first of all, let's just find out real quick. What's 15 times 4? 60. So $15 times 4 is 60. You have how much money? 65. So the answer to the question is yes. Can you fill the tank 4 times? Yes, you can. Yes. Okay. But let's continue on. Here's my inequality. 15x has to be less than 65. Alright, let's think about this. It costs $15 to fill up the tank. If I fill it up once, that's $15. If I fill it up twice, that's $30. If I fill it up 3 times, that's $45. Got it? So on and so forth. So these numbers here, are the number of fill-ups. Okay? Now you're 15. Let's come over here. Now let's apply it to this, okay? 15 is obviously the cost, 15 is obviously the cost of one fill-up. Okay? X is the number of fill-ups. And 65 is your what? It's your total money that you have. And that's it. Pretty simple, guys. That's what 15 stands for. What X stands for in 65. Now, can you completely fill up the gas tank? Yes, you can. Definitely. Number 69. Alright, here we go. We're going to use one of these formulas for number 69. Now it says, what is the average speed of a runner who completes a 10,000 meter race in 25 minutes? Now guys, we've talked about this before, back in lesson 1.1 I believe. When you're dealing with speed and time and distance, this is what we use. Rate times time equals distance. Okay? So, we're looking for the average speed. That's the rate. So leave R alone. The total distance is 10,000. The time is 25 minutes. So we're dealing with meters and minutes. So your answer, students, is not going to be miles per hour. It's going to be meters. Meters per minute. Okay? Alright, back up here. Forget this equation for a second. Let me ask you a question. If I had something like x times 6 equals 12, you know the answer would be what? 2. Right? Because 2 times 6 is 12. However, what if you could do this in your head? Well, then you would take the number over here all by itself and divide it by this number here. And 12 divided by 6 is 2. Alright, so back to this. I'm not sure what times 25 gives me 10,000. I think it's 400. But I'm going to take this number here by itself. And I'm going to divide it by 25. Let's see what we get here real quick. Yes, 400. So, 400 times 25 equals 10,000. So what's my rate? 400. 400 what? Meters per minute. Meters per minute. Because you're dealing with meters and minutes. Alright, number 69. Excuse me. Number 71. A car travels 60 miles per hour for a distance of 300 miles. How long did the trip take? Once again, guys, we're dealing with speed, time, and distance, so we're going to use our formula. Rate times time equals distance. So here we go. Your car travels 60 miles per hour. That's your rate. For a distance of 300 miles. How long does it take you? So we're looking for t. Now, some of you can do this in your head. Some of you realize that 60 times 5 is 300, and that's fine. The answer is, 60 times 5 is 300. And that's the right answer. But if you could not do that in your head, remember what I showed you back here a second ago. Take this number here all by itself and divide it by this number over here. So if you take 300 and divide it by 60, you will get 5. So 60 times 5 is 300. So my time is 5. Now hold on. 5 what? Well, let's come back up here and look. A car travels at 60 miles per what? Hour. So your time is in hours. So it's 5 hours. Okay? Not too difficult. Okay, number 73. You must measure the temperature of a substance in a chemistry lab, and it measures 32 degrees Fahrenheit. What is that temperature in Celsius? Well, if you look at your group of formulas up here, to me it's pretty obvious. We're going to deal with the one that's temperature, okay? So Celsius equals 5/9 times F minus 32. Now the temperature is 32 degrees Fahrenheit. So where the F is, I'm going to put 32. So we have 5/9 times 32 minus 32. And obviously my answer is going to be 0 degrees. degrees Celsius because 32 minus 32 is 0. And 5 nines times 0 is 0. So your answer is 0. Number 75. We're dealing now with a patio, and they give us the area. The area is 80 square feet. Alright? So, once again, I like to say this a lot. Pretend you're up in the air, hanging in the air like a bird, just flying up in the air. You look down on the patio. The patio is not going to look like this, or like this, or like this. It's going to be a square or a rectangle, okay? And we know that because it says it has a length and a width, okay? Now, we know the length is 10 feet, and we know the area of this entire patio is 80 square feet, okay? So actually, this is pretty simple. What would this length right here have to be? 10 times something gives me an area of 80. Well, the answer is obviously 8. But if you want to use a formula like we're supposed to, that's fine too. Area equals length times width. My area is 80. My length is 10. And my width is W. So what number would you have to put in here? 10 times what gives you 80? 10 times 8. So your width is 8. 8 what? Well, we're dealing with feet. So 8 feet. Alright. Number 77. Last one. In the diagram, X is the length of the airplane. Y is the wingspan from here to here, or this right here. Okay? So this is your X. This is your Y. Now, what is the equation 1.212 Y equals X say about the relationship between the length and the wingspan of the passenger jet? Okay, listen carefully, and I'll explain this to you, okay? I have 1.212 times what? Y. What is Y? The wingspan. So I have 1.212 times the wingspan equals what? X. What does X stand for? The length of the plane. So what's the relationship? To me, it's pretty obvious. Whatever the wingspan is, you have to multiply it by 1.212 to get the length. So the relationship is that the length is 1.212 times longer than the wingspan. I mean, guys, think about it. I mean, you're taking the wingspan and you're multiplying it by 1.212, which will give you a longer, a bigger number for the length. The length equals taking the wingspan and multiplying by 1.212. So, what relationship do I see from this? I see that the length is 1.212 times longer than the wingspan. Now, is the passenger jet longer than it is wider, or wider than it is longer? Well, I just told you right here, the length is 1.21 times longer than the wingspan, so the jet is longer than it is wide. And that's it. Guys, I know these problems can sometimes be difficult, word problems like this. I hope this homework help video has been a help to you. If you have any questions at all, please do not hesitate to call or email.